Good morning, boys and girls. Mr. Giomini. You probably thought you would have to hear my voice for the next 2 days, but you're going to have to hear it today. Not so much tomorrow, but today. Today we're talking about properties of exponents. Yesterday when I was there in school, we talked about exponents, which was a review. Now we're getting something different. It's called properties of exponents. So we know that an exponent has both a base and a power. But before we even get to that, we are going to first do a little warm-up. So whoever the sub is today, he or she is going to pause the video. You have these. Ladies, why don't you grab a scrap piece of paper, and then once all the girls have, the boys can then get up and do the same. I want you to evaluate. Now, evaluate is just a fancy word for solve. Okay, so you're going to solve for these. So 3 to the third power, I want to know what that equals. I don't want to know what equals 3 times 3 times 3. I want to know what 3 times 3 times 3 is. So go ahead and solve these. So whoever's in charge there, the sub, if you graciously pause this, and then we can come back and check the answers. Go ahead and hit pause. Okay, I'm back. Now we are going to check our answer. So 3 to the third, 3 times 3 times 3, that should be 27. 4 times 4 is 16, times 4 is 64, times 4 is, I think, 256. Now b squared, now we're substituting in 4 for b, so it now becomes 4 squared. That should also give me 16. And then finally we have 4, n to the second power, n squared, times r for n equals 3 and r equals 2. So I substitute in, so it becomes this, and then I substitute in the 2 for the r. So we should know that this really is written as 3 to the second power. And I'm going to put this in parentheses to show some separation, times 2. So 3 to the second power is 9. 9 times 2, that would give us an answer of 18. Okay, I'm not going to worry about this just yet. We'll come back to this maybe another time. So today we're going to learn to apply the properties of exponents and to evaluate the zero exponent. So for instance, we have 10 to the 0 power, or 4 to the 0 power, and I think we all remember that is equal to, who can help us out? Everyone raise their hand. What is 10 to the 0 power, 4 to the 0 power? Go ahead, call in somebody, sir. Yes, hopefully you did say 1. Excellent. And anything to the 0 power does indeed equal 1. Alright, so the factors of a power, such as 7 to the 4th, can be grouped in different ways. So we can do this in different ways. Know this relationship of the exponents in each product. So we could have 7 times 7 times 7 times 7 is 7 to the 4th. 7 times 7 times 7 in parentheses, so order of operations tells you this first, times 7 is 7 to the 3rd times 7 to the 1st, which equals 7 to the 4th. We could group it into two things here, 7 times 7 times 7 times 7. Now, you should begin to realize 7 to the 3rd times 7 to the 1st. Notice the bases are the same. They're both 7. The exponents are not the same. So what did I do to the 3 and the 1 to make it 4? Well, of course, I added. So whenever we have the bases being the same, all we do is then add the exponents. So for instance, bases are same, both are 7. So we go 7 squared times 7 squared. All we do then is add the exponents. That's how we get our 7 to the 4th. So taking a look. Multiplying powers with the same base. Now this might be good to put in your guided note or your quad notebook here. To multiply powers with the same base, keep the base and add the exponents. Now here's the key word here, boys and girls. When multiplying powers with the same base, we don't have different bases. So this will not work if it is 4 to the 2nd times 2 to the 7th. The bases are not the same, so this will not work in that instance. And add the exponents. So their example, 3 to the 5th times 3 to the 8th. Using numbers, we just take the base is the same, 3, and we just add the exponents. 5 plus 8 is 13, so we have 3 to the 13th power. Algebraically, we use b as our base. B to the m power times b to the n power, that is b to the m plus n power. Okay? So let's take a look at a couple examples. It says write the product as 1 power. First thing I'm doing is I'm identifying to see if the bases are indeed the same. 6 here, 6 here. Yes, they are. So now that they're both the same, I know that I could simply add exponents. So now I just look at the exponents. The exponents are right here. 6 and 3. I add those two, and I am going to get 9. So it's 6 to the 9th power. Simple enough. Now, it's not asking me to evaluate. It just says write the product as 1 power. So if we're just evaluate, then I would then have to figure out what is 6 to the 9th power. But it says write the product as 1 power. I am just simply combining like bases and adding their exponents, and I get 6 to the 9th. Now if I take a look at the next one, I have n to the 7th times, n to the 5th times n to the 7th. Again, I notice their bases are the same. Bases are the same. So they have to use this with variables, or I can also use with whole numbers. So taking a look, I add the exponents because the bases are the same. They're both n plus 5 plus, or sorry, n to the n, or 5 plus 7. So we have 5 plus 7, I believe, gives us 12. So it'll be n to the 12th power. All right, let's try another one. Write the product as 1 power. So I have 2 to the 5th times 2. 2 to the 5th times 2. Is there a power there? I see the bases are the same. Is there a power there? Discuss this real quick. Go ahead, substitute. If you want to hit pause, get some ideas from the kids. All right, now here the key is think 2 is equal to 2 to the 1st. Because if I want to think of that, 2 to the 1st does indeed equal 2. So, knowing that, this really becomes 2 to the 5th times 2 to the 1st. So again, bases are the same. I'm going to just add the exponents. I get 5 plus 1, which gives me 2 to the 6th power. Take a look here. We have 24 to the 4th times 24, times 24 to the 4th. So our bases are both 24. That's great. Now I just look at the exponents, and I'm going to add the exponents. And I get 24, and then 4 plus 4. That gives me 24 to the 8th power. I would like you guys to solve these. I'm going to pause the video real quick, or the substitute should pause the video. Go ahead and solve these on your own. All right, independent. Actually, why don't you group up a young lady and a boy, group up together, knock these two out, get them in your quad notebooks. You have examples. Okay. I would also write the problem out. Write 4 squared times 4 to the 4th. Do not just write the final answer because you'll have an answer and you won't know what that's for. So make sure the problem. Okay, substitute pause this please, and then give them about a minute. Okay, you should have finished that. So we have 4 to the 2nd times 4 to the 4th. That gives me the bases are the same. They're both 4. So I just add 2 plus 4 gives me 6. Next one I have x squared times x cubed, or x to the 3rd. So now I see the bases are the same. So all I do is I just add the exponents. And 2 plus 3 does indeed give me 5. So it's x to the 5th power. Go ahead, try these. Again, substitute if you'd gladly or graciously pause this. And keep the kids in the same groups. Okay, so this one here, I notice I have x to the 5th times y to the 2nd. First thing I notice, bases are not the same. So I cannot combine these exponents. So this answer will just stay the same. Or this problem will just stay the same. X to the 5th times y squared. Cannot combine, the bases are not the same, so it stays. I go to this one, 41 squared times 41 to the 7th. I see the bases are the same, so I just add the exponents. And that should give me 41 to the 9th power. Alright, hope this helped you out. Another video will come up here shortly when we are now going to divide. So we multiplied, now we divide. Now I think about this, when we multiplied we added the exponents. What do you think is going to happen to the exponents when we divide? Go ahead, pause or stop this video now, and then why don't you generate some dialogue sub as to far as what's going to happen when now we divide exponents. Alright, with the same basis too. Take care. Bye-bye.